what this value is.
Mhm.
Once you find what that value is, you just plug it back into here, and this is your answer.
Okay. Slow down. Value of this. I plug back into here.
No. Okay. Let's see. This is our original problem, right?
Yeah.
This is our original problem?
Yeah.
To find the derivative of this,
Yeah.
since there's two functions,
Yeah.
you see how it's x to the fifth?
Yeah.
And it's also this 3x over this.
Mhm.
Those are the two parts to it. Since it has two parts, you have to take the derivative of part one. You have to take the derivative of part one with this part still left in it, and then add the derivative of the part two, if you want to think of it like that. So, like, the derivative of part one is 5, this to the fourth. Then the derivative of the part two is, I just wrote derivative of part two. And in order to find this, you have to use quotient rule.
Which I did.
Yeah.
I have that.
And then, so once you got the answer, you just plug the
Well,
answer
do I need to
in
like
for
reduce
this.
it any further with it once I like use the quotient?
Mm-mm.
Like I'm talking about like when I use the quotient, do I need to like reduce that whatever I got
I mean,
before I like plug it into that?
yeah, you reduce it into.
Because this is what I'm left with, and I found out that I couldn't like factor it any further.
Well, there's a 3x and a 3. Well, yeah, let's see. 3x, that's 4. You might be 3x. This is a 3. Because if that was a 2. Oh, yeah.
You guys, no. I'm just saying. I'm just saying. I'm going. You guys,
Oh, yeah.
you guys stay until security gets out.
Yeah, she just.
They
told
just
us
did.
to-
Oh, who?
Yeah, the
So-
lady came in and was like, "Yeah, we gotta go." But
Lady this time.
yeah,
Oh.
I just had to. Yeah, I just thought I want to make sure I'm doing it right. When you take a derivative of anything like normal, like if it's x to the fifth, it's really like. It's really like side x to the yeah times the derivative of x, which is 1. Yeah, so that's so it's basically a quotient rule every time.
You mean chain rule every time?
Chain rule, but product rule is really like chain rule, but since that's always going to be 1. Because I mean, I'm not power rule.
Oh, power rule.
Power
Yes,
rule
yes,
is
yes.
really just chain rule.
Right.
It's 1 every time, you know.
Don't worry about it.
Yeah.
When it was something more complicated next in there.
Okay.
Don't worry about it. Right.
Okay. All right. Have a good night. All right. You're gonna be fine, man. I can. Well, I'm gonna be here early too. If you wanna work on stuff.
How early?
I'm gonna try to get here around, I don't know, 5 something.
That is
4 or 5.
That is super late.
Yeah, I mean, the thing is, I don't want to leave work too early. Depends when I could get off.
It's
Yeah.
it's a bad idea to be asking if we're this close to having a test starting.
But basically, the way to think about it, like everything, it looks complicated, but all it is using other stuff we've learned. That no question is going to ask you to use something they haven't already taught you.
They do that on the final.
No, they don't. They just phrase it. They throw in some other stuff, but you like, cause like the way I got out of thinking that, like in my engineering classes, they would basically do that. They would throw in a bunch of stuff to complicate the problem, but basically you have to break it down into what you know. So like with chain rule is like always just the derivative of the whole thing, and then you take the derivative of the inside.
So a few things that I do know is, well, a few things I don't know is it. What was it? The 3.10 that we had earlier was much complicated compared to the stuff that we
Yeah.
looked over, like inverse of trig and that trig derivatives. It's a bit complicated for me. And then there was like, in the chain rule, I'm still trying to get.
Yeah, the chain rule is basically the hardest one of them all, but if you really look at it, it's really simple. All it is the derivative of the big thing, and then you multiply it by the derivative of the inside. That's all it's saying. It's
Derivative of the distance.
times the derivative of the inside. And the only reason why it gets complicated is
Yeah.
because the derivative of the inside might have a bunch of steps.
Yeah, yeah.
So you have to keep going and going and going. But in short, it's just derivative of the whole big thing times the derivative of the inside. If you could remember that, and just no matter what, just write it,
Yeah.
it'll be fine. Like, that's why, like, I mean, you don't think that, I mean, you got it. Like, the only problem was with, like, if you would have got that problem wrong, you knew how to do it. The only thing that would have stopped you was that you thought you were taking the derivative one way, but you didn't use chain rule. I mean, quotient rule.
But now I did.
Yeah, now you know you had to use quotient rule.
And we didn't finish the rest of it.
Yeah, because, I mean, you found the answer with quotient rule. All you have to do is plug it in.
Okay.
Yeah, but I'm gonna try to get here like like probably 5 is the earliest I could get here, just because.
Yeah. Don't forget, I do have another class, you know.
Yeah, I know.
I have like a double workload. Actually, it's almost like triple.
Yeah.
Because I have a lab and 2 lectures.
Oh, yeah. That's tough.
Yeah, it's kind of like hard for me to like stay up because of all those hours I sit.
Yeah, I know what you mean.
Yeah.
We'll get through it, man.
Yeah.
All right, man.
See ya.